All right. You can see the question on the board, and want to take um questions from what we have discussed earlier. All right. This has been an hour-long classes, and my students are all seated behind the camera. So, want to take these questions. All right. So, I'm sure that you all understand or you know the answer to this question. Two of us. Eh? So, let's make the question together. What's the answer?
Angle which S magnetic field makes it horizontal is called the answer is angle of the
The answer is what?
angle of the
So, look at the important points to note are uh, Earth magnetic what? Field and what? Horizontal. So, another way this question can come, just like you saw when I was, explaining, is you use the word what? Magnetic needle. Eh? The axis of the what? So let's assume that this is axis of the magnetic needle and this is the horizontal. This is a what? Horizontal. Now listen. Now, this whole thing, some of you don't understand. Maybe you are saying this for the first time. Listen. We are talking about whenever you have listen, whenever you have a magnetic needle, let's assume that this is what? A magnetic needle. And you suspend it freely with a what? A cord. What will happen? It will settle to what? The magnetic north and south pole. Two of us. And depending on your position on the earth, two of us. So let's draw a diagram of the earth. Let's assume that this is the earth now. Alright? Now, if you are here in the earth, this is your horizontal, two of us. If you are here on the earth, this is your horizontal. And this is the earth magnetic field. This is the Earth's magnetic field, north and south pole. Are you with me now? So if you carry a needle, eh? If you carry a needle, people have exposed yourself and I'm using in your class. You know me.
Why is your mic so loud now?
You will see it online, I promise you. I will write the name of your school. I used to use it in your school. Yes. Yes. Don't mind this human Now listen, if you carry a needle, if you carry a needle and you are here, are you getting me? This is your vertical. If you are here, remember this is equatorial region, two of us. And this is your what? The polar region. And we as Nigerians we are here. Right? So this is your vertical and this is your what? Horizontal. Irrespective of your vertical and horizontal, once you suspend a magnetic needle, it's going to align the earth magnetic north and south pole. So if I'm here, if I suspend my rope, remember this is my horizontal. If I suspend my rope like the way I am like this now, this is my horizontal. This is my horizontal here. So it's more like I'm bending like this, right? So if I suspend my magnetic pin or needle, what will happen? It's going to align to my horizontal. Look at it now. If I suspend to align. Why? Because this is earth magnetic north and south pole. The thing must be like this. It must align to the magnetic north and south pole. Now listen, if like I said before, this is our horizontal. This is our horizontal. So this horizontal you are seeing here is this our own horizontal. So if we suspend the magnet, it will be like this. Look at it. The magnet must align like this. If I'm here, the magnet will stand up. If I'm here, the magnet will stand like this. But if I'm here, this is my horizontal. So the magnet is aligning to my horizontal. What that means is that as I'm here now, magnet will be like this because we are the equatorial region. But when we are the polar region, I get me, when you suspend the needle, it will be like this. And this is their own horizontal. This is what? Their own horizontal. So if I am at the polar region, places like Russia or Antarctica, my magnet will incline like this. So it will make an agonizing with my what? Horizontal. Make an agonizing with my what? Horizontal. Now, irrespective of where you are, the angle to which the magnetic pin or the earth magnetic field makes with your horizontal is called angle of shift. Alright, let's try and answer another question. Now, we have another question. All these questions are under magnetic field, and we have a few other topics along the same topics, okay? So I want to see if we can answer 5 questions on all these topics. So this is another question. Can we just look at this question? Okay? Alright, you can read with me. Let's go. Now, you need to understand the real life application of this thing. Have I told you that the Earth's geographic location and the magnetic geographic location, they are not aligned? Do you remember when we're discussing angle of declination? So let's do a diagram so that every other person can understand. So now this is the Earth. This is geographic north and south pole. North and what? Now the magnetic field. Now this is the Earth behaves as a magnet. The Earth behaves as what? A magnet. Now, but the polar or the polarity of the Earth is something like this. So the angular difference between the North Pole and the Earth geographic meridian or North Pole of the Earth and what? The magnetic meridian or the magnetic North Pole, that angular difference on angle of what? Decline what? Nation. Are you with me now? So there's a value. And the value is different for each place where you are, where you find yourself. Let me use that word. Are you with me now? So let's look at the question. It said at the location of the Earth where the declination is what? So at this place that we're talking about, the declination is what? 15 degrees. Now, what is the needle reading? What's the magnetic needle or the compass reading? The reading of the compass is what? 50. Now listen, the compass is a lateral, it operates laterally and it's going to align to this north and south pole, right? It's going to align to the Earth magnetic north and south pole, this one here. Are you getting me now? But geographically, your north pole is here and your what? South pole is here. So the difference is a worry, the difference is a problem, alright? That difference is what? Problem. It can lead to misdirection. It can lead to what? Misdirection, especially when you are going to a specific direction. Are you getting me now? So what you do is that whatever you get from the magnetic what? Meridian, which is given by what? Your compass needle, then you have to do a plus or a minus depending on what? So what we are seeing now, the Earth magnetic field goes like this. Sorry, the magnetic field goes like this, right? So in order to be consistent with what? The geographic north and south pole, we must add the angle of it to whatever we have, right? We must add. So let's add. You understand what I'm saying now? So when we add to what do you call it? This 50 degree that is given here, if we add the angle of declination, you have what? 65 degrees. So 65 degree what? North what? North what? 65 degree north east. So which of the answers is correct? A is the correct option. Do you understand? You understand this, right? I'm serious. Eh? Okay. Let's go. Now we have another question. This is the third question now in the series of questions that we are. Alright, so are you with me now? Now, like what I'm saying, this is number 2 question. Alright, so let's look at the question again. Now the question says what? The magnetic field strength at a point close to and lying along what? The axis of the solenoid will be greatest if the core of the solenoid is made up of. Now listen, we're talking about solenoid, alright? Solenoid is, a coil of wire. A coil of what? When you have a coil of wire and you pass current, alright, you pass current through the coil of wire, it creates a magnetic field around here. Are you getting me now? So the question says, The axis of the solenoid will be greatest if the core of the solenoid is made up of what? Hmm? Is it copper?
Yes. What do you think? It's over.
Now let me be clear. Let me be clear. If we have a metal inside, or our bar, a metallic bar that we want to convert to what? Want to convert to what? Magnet. This core, the core of the bar, the magnetic field will be stronger if it is made up of what? No, iron. Remember. Why? Because iron is a ferrous magnetic substance. We have the magnetic substance that we have are ferrous magnetic substance, diamagnetic substance, and also paramagnetic substance. What is a ferrous magnetic substance? A ferrous magnetic substance is a strongly magnetic substance like your iron and nickel. What is a paramagnetic substance? A paramagnetic substance is a weakly magnetic substance. Paramagnetic is what? Weak magnetic substance. Are you getting it now? So when a substance is ferrous magnetic substance, it's also paramagnetic. I told you that before, right? But when a substance is diamagnetic, it has no magnetic effect. And the magnetic effect of the substance depend on what? Depend on what? Depend on what? The vacance on the orbital. Vacance on what? On the orbital. Are you getting me now? And so when you have partially filled orbitals, it becomes a magnetic substance. But when you have, orbitals that are filled, you have what? A diamagnetic substance. I don't know if you understand this, right? Good. So, but this solenoid is made up of what? The solenoid is made up of what? Copper. Why? So that it will increase the flow of the current. So copper is always a very strong conductor. A very what? Copper is always a very strong what? Conductor, right? Yes. Now, if the conductor is flowing, if the current is flowing at will, they have what we are saying is that we are trying to associate the magnetic strength with what? A ferrous magnetic substance. That's what the point is all about. So it's not about what the material that is conducting, it's about the fact that iron is a strongly magnetic substance. So if the core is made up of iron, then we have what? A very strong magnetic what? A very what? Strong magnetic what? Field strength or magnetic field. Are you getting me? Are you with me now? Alright, that's the answer to that question. Now, this is the fourth question. Can you look at this question carefully?
Yes.
Now, if you follow this class from beginning to the end, the answer to this particular question you already have it. Because I was drawing a diagram of the earth. Huh? So look at the question. Say the angle which a suspended magnet will what? You can pause the video to read the question. Will make with what? The horizontal at what? The earth magnetic north pole? Yeah. And at what? The earth magnetic equator here. So let's assume that the magnetic north pole is here and the equator is here. Are you getting me? So what angle will what? The needle make? I told you when it's here, it will always be right. So it will make a 90 degree with what? Horizontal. Then when it's here, it will be like this. This is the horizontal line, this is the magnetic needle, it's parallel. So parallel means angle 0. Are you with me? So 0 degree here and 90 degree what? Yeah. So the first one is what? Magnetic north pole, 90. Then the second one is what? Magnetic equator, 0. So 90 and 0. 90 or what? 0. A is the correct answer. I hope you understand this. You can go back to the first question. I explained this very well. Alright, let's take the last question. Now this is the last question and the most interesting of all questions. Now, it's very important that we understand some of the things that led to some of these diagrams, okay, or this kind of question. Alright? Now, before you read the question, I like to do some explanation so that when you read the question, you know what you are reading. Now, first of all, when you are discussing along the lines of this topic, the first thing is that we have what? Some laws that determine what? The direction of what? the direction of the field around a current carrying conductor. That is, if you have a wire carrying current, it has a field around it. That's established. That is a fact that is established. So, what is the direction of the field? What is the direction of the magnetic field around a current carrying conductor? There are two laws that help you to determine the direction of what? The field. The first one is what? The first one is what? Maxwell's what? Maxwell what? Right hand what? Screw rule. Then the second one is what? Length fish what? Rule. So what are they determining? They are determining the direction of what? Of the magnetic field around a current carrying conductor. Two rules. A wire carrying conductor. What is the direction of the magnetic field? So this one says that as you what? Turn your what? Your screw, the direction of the motion of the screw points to the direction of the what? Magnetic field. While the direction of the turning points to the what? The direction of the field. The direction of the motion points to the direction of what? The current. While the direction of the turning points to the direction of what? Magnetic field. That's it. The same thing with pledge fish rule. Are you getting me? Now, the next one is that there are also laws pointing to the direction of what? The direction of force of what? The direction of force of what? Of a current carrying conductor. The direction of force of a current carrying conductor, not just the force of the current carrying conductor, but in a magnetic field. So if I have a conductor in a magnetic field, not at South Pole, are you getting me? And the current there's a current in the wire, are you getting me? There's a direction of the motion of this wire. So that one is determined by what? Fleming's what? Fleming's what? Have you forgotten now? Fleming's left hand rule. So we use our left hand. Now, what does this law state? The law says that if this first forefinger or your first finger is or forefinger or first finger points to the direction of magnet, so it's always the direction of the magnet. The first finger points to the direction of what? Magnetic field. You can see the magnetic field starts from the north and to the south. Alright, the field goes out from the north, it goes outward from the north, and goes inward to the south. So this first finger points the direction of the magnetic field. Then the forefinger points the direction of what? Current. So this current is going up, so it means that this is what we are talking about. The middle finger points the direction of what? Current. Then your thumb will point the direction of motion. So if we have current going this way and magnetic field going this way, right? Can you see? Current is going upward, magnetic field is going this way. So what do you discover? So the motion will what? Go in the direction of what? The thumb. Are you with me? So as we're saying, we determine what? The motion when we have a magnetic field and a current. So this one points, the first finger points this direction, and your thumb points what? Your middle finger points what? Upward. So this way and upward. It means that your thumb goes this side, sorry. So this one points upward, this one goes outward, so your thumb goes this side. So the motion of this copper, this wire will go inward. So let's read the question, then we can now understand what we're talking about. So what's the question? The diagram shows a current carrying copper wire placed, are you there?
Yes.
Placed between what? Two poles of a horseshoe magnet. The wire will tend to move where? Where will the wire move? Remember, I told you North Pole. The direction of North Pole is outward. The field is always outward. While South Pole is always inward, right? So it means that the thing is moving this way. Now, when you apply your Fleming's left hand rule, This direction, the first finger or forefinger goes this way. Current goes upward. This is your current. Then this will go inward, inside the paper, into the paper. That's our answer is what? Option what? B. That's the correct answer. I hope you understand this. Thank you. Please you can play the video over and over to understand the topic. Now I'd like you to go and solve many more questions, get your problems and use your creativity to find your answers or drop the questions on my comment section and do a video to respond to all your questions. Thank you. Remember to subscribe and share the video.